two presenters today are Aaron Puryear with Old Dominion Electric Cooperative and Josh Ludgate with Exact Energy. They're here to talk to us about energy efficiency measures that can be used in an agricultural setting. They're doing a joint program, so I'll read a short bio for each before handing it over to them for their presentation. All audience members will be muted, but if you have any technical difficulties during the presentation, please chat us in the box in the bottom left. We will also accept questions via that same chat box throughout the presentation that we will ask on your behalf at the end of the presentation. So please make sure if you have any questions to chat them over to us, and we can get the Q&A started immediately following the presentation. With that, I'd like to introduce first Aaron Puryear. For almost 30 years, Aaron has worked within the electric utility industry in a number of capacities, including rates, regulatory, retail electricity, and in energy marketing and trading. As the Manager of Member Services and Energy Innovation Planning at Old Dominion Electric Cooperative, her responsibilities include the development and coordination of energy efficiency and demand response programs of ODEC's 11 member distribution cooperatives, as well as communications and project management of the load research activities. Joshua Ludgate is the President and CEO of Exact Energy, Inc. Josh founded Exact Energy in 2009 with the goal of providing energy efficiency and design principles to the agricultural and commercial industries. A graduate from North Carolina State University's Professional Energy Management Program, Josh has extensive knowledge in implementing energy efficiency practices. From 2010 to 2016, he completed 2 pilot programs through Virginia Cooperative Extension, completing well over 100 energy audits. In addition, he has worked as a technical service provider for both the U.S. Department of Agriculture and the Natural Resource Conservation Services, providing energy audits and design plans. Through Exact Energy, Josh and his team educate on total farm energy management practices, speaking publicly and holding agricultural energy efficiency and renewable energy workshops in Maryland, Delaware, and Virginia annually. Josh and Exact Energy were awarded 3rd place in the Commercial Energy Efficiency Award category in 2016 at the Virginia Energy Efficiency Council's Leadership in Energy Efficiency Awards. And with that, I'm going to turn it over to Aaron and Josh. Thank you for being with us today.
Hi, good afternoon. Thanks for joining us today. Josh, want to say hey?
Good afternoon, everyone.
We appreciate this opportunity that Chelsea and Jessica offered to us to talk a little bit about what we've been doing in the agribusiness world. Chelsea, am I going to have control of the slides, or do you?
We do, so you can just say next slide and we'll take care of it.
Okay, why don't you go ahead to the next slide. I've got these first few slides in here just to talk a little bit about farm use electricity. I don't know who all the participants are on the call, so I don't know what your familiarity is. This particular statistic came from 2005, so it's a little bit dated. I'm working to get a more current number. But with regard to the farm's production expenses, it's probably a whole lot more than 6%, probably a whole lot more than $10 billion as part of their total expenses. Those come from lighting, ventilation fans, heating, refrigeration, materials handling, the water pumping. So it's a huge cost, and the farming community, the margins are typically pretty slim. So any and everywhere where they can cut costs is very important to them. So let's go on to the next slide. So where are the savings when it comes to energy? And we have to remember it's not just electricity, but it's the fuels, the gas, the propane, the diesel. We like this pyramid because actually this can be used outside of agribusiness. It can be used anywhere. The first thing that you really want to do is an analysis of where your energy costs are being expended. And then the first step you want to take is with conservation. Where can you cut the corners to reduce your energy consumption? The third step is energy efficiency. and then time of use management, and lastly is the renewable energy. So let's go on. We're going to just walk through these steps real quick. Can you do the next slide, please? Okay, step one is the energy analysis, which includes an audit or an assessment of how the energy is being used, what components make up that energy consumption. Next slide. Energy conservation, this is what we were talking about, where you can just find ways, behavioral changes to conserve on the energy usage. The next step, energy efficiency, which is maybe not always a reduction in energy, but using energy more efficiently. So this is where you upgrade your equipment on the fans and the pumps and the lighting. Next slide. Step 4 is the time of use management, and this has more to do with using energy during the peak times of the day. A lot of that has to do with how the rates are structured from the utility to the farmer, but sometimes using equipment in an off-peak hour can save money and energy, not just in that current period of time, but in the future as well. And step 5, lastly, is renewable energy. So that's kind of a last resort. So let's go on to what we've been doing in this arena. The next slide. As you all may be fully aware, electric cooperatives pretty much got their genesis, their start through the farming community. We were rural users where the investor-owned utilities could not, because of the cost, extend the lines out to the farming community. So through the REA efforts that Franklin Roosevelt put together back in the mid to late 30s, electric cooperatives began providing electricity to the farming community. As such, electric cooperatives tend to have a soft spot for the farming community, and we'd been doing some programs in the residential arena, a very few number in the commercial arena, but we wanted to reach out to the agribusiness sector. So we started talking with DMME, USDA-RD. We had Maria Papadakis, who is a professor at JMU at the very beginning, just trying to look at different programs that we could do in that arena. Robin Jones was very key in these programs, and I'm thinking that she's probably on the call as well. One of the options that we had was to do some funding for some energy audits. But go on to the next slide, please. And audits are a great first step. That's going to be how you identify what measures need to be taken. But as we mentioned, the margins are pretty slim, and if you pay for an audit and provide a report to the farmer saying, okay, here's what you need to do, here's the improvements that you need to make in order to reduce your energy use, most of the time those costs are just very prohibitive. They can't do that. So then the dollars that you spend on your audit are all for naught. So we were trying to see what we could do. We were made aware that USDA-RD, through their REAP program, and NRCS had some funding available through the Farm Bill for both grants and loans. So we started trying to find ways that we could educate and inform the farmers of that step. Go on to the next slide. So education and awareness. We pulled a little team together, and we met regularly. It was Oriette Tucker from USDA-RD. We had David Faulkner from NRCS, Josh Ludgate from Exact Energy. I think Stephen Person from VX came to a couple of the meetings. Maria Papadakis from JMU was involved. We had some folks from Virginia Cooperative Extension Service, Martha Walker and John Ignash, specifically working together to put these workshops so we could help inform the farmers of all of these opportunities and what was involved. Go to the next slide, please. Oh, no, actually, let's just stay here. On the format, the way we structured these workshops, we did them by sector so that it could be very specific to what their needs might be. So we did poultry. We had several in the poultry arena. We did dairy, swine. We did one for wineries and cideries. we did greenhouses, and we did tobacco. The format was laid out so that we had an energy expert, and most of the time it was someone from the academia world. We had a professor from Mississippi State. We had someone from Auburn, and we had the gentleman from University of Wisconsin, and they were there to address specifically the new and emerging technologies and the best practices in order to make their operations more efficient. And then Josh talked a little bit about what was all involved in the audit process, and I don't know whether you're going to go into that any, but he explained to them in great detail what all the audit included and what the report would look like. And then we had an opportunity for Laureate and David to talk to them about the funding opportunities that were available. So we did between 2013 and 2016, this last year, we had 10 or 12 workshops. Virginia Cooperative Extension Services, Martha and John had actually been the recipients of some grant funding from the Tobacco Indemnity Commission, specifically for the south side and southwestern part of Virginia. So they have also conducted about 20 education workshops during that same time period to work with the farming community on improvements. They also had some dollars to fund some audit processes and some improvements as well, I do believe. So let's go to the next slide. Oh, and the next slide.
You want me to take over now?
Yeah, well, let me just start by saying we'd been doing those education. We really wanted to move into the next step, which was to look at some specific programs where we could address improvements. And the lighting arena was, I don't want to say low-hanging fruit, but it's a good place to start, particularly with the poultry farmers. So ODAC and DMME partnered up together, each putting some funding into this project to do a demonstration study. And we've been working through Josh and through Southside Electric Cooperative. Josh had done a number of energy audits for poultry farmers in that area. So we identified several that we could work with, and then I'll let Josh take it from there.
Well, thank you, Erin. So as the slide says, in 2015 and 16, our group discussed that availability of finding those farmers that haven't made those changes yet within their lighting or the scope of their lighting programs that they've got. Our plan was to find those farmers and go ahead and provide LED bulbs to make that switch for them. And also with that to install some metering equipment to do some verification and measurement to really see if this was the way to go. With that, we were able to get these technologies installed on a few farms, which we're going to go into, and I've got some numbers to back those up. We focused on the small sample of producers that had either, for whatever reason, not made that transition over based on cost, or that their integrator might not have wanted them to make that change, which is something that we do run into depending on integrator. Next slide, please. So the test farms we identified were of typical size, utility rate structure. The average age, so they didn't, one wasn't brand new and one was older or this or that. They're all pretty much the same age and condition. The houses on each farm are located next to each other to better monitor production and energy consumption rates. So what we were able to do was, meter one house right next to the other house where we made the changes so we could tell right out of the gate, what's working and what's not working. The only difference between these three farms that we decided that were test farms is that one was a breeder farm rather than a typical broiler farm that you normally find in Virginia. And I'll go into that in a second. Next slide, please. So the difference between these farming operations. So a broiler farm is typically 5 to 6 flocks per year per house. An average flock period can range from 42 to 60 days. So within that period of time, there's segments of the house that's divided up to have these birds in. So the middle part of the house, where they would section the baby birds, typically have 24 hours of light or 18 hours of light. And then after they grow in age, they start dimming the lights. They open up new sections of the house to grow the birds in, and they'll essentially use less lights because of the lighting requirements for the bigger birds is just less. The breeder farm is typically 2 flocks per year, and the average flock period is 600 to 660 days. Within that size of farm and that operation, you have a lot more light intensity on for more hours of the day to stimulate the reproductive systems within the birds, and that enhances the egg laying. Next slide. So the broiler farm, we did the study where we wanted to see how this could impact this farm the most. Is it going to work better in the breeder houses or the broiler houses? So we did this. We studied these. The birds are delivered to the farm at 1 to 2 days old. They're meat chickens for human consumption, so the spectrum of light is different for these birds versus a breeder house. In the broiler farm, typically because they're brooding those smaller birds, they have to run a lot of heaters in there to keep the birds at about between 86 and 90 degrees. So the electrical aspect of those houses is not at that time as much as it is on a breeder house, but it is considerably large and very energy intensive. So they are heavy on the ventilation and tunnel side of the fan usage is based on the latter part of the bird's lifespan in the house. As far as the lighting and the feed motors, it's a medium energy intensity based on the wattage of bulbs that they have in those houses and, again, how long the run times are. Next slide. In the breeding and egg-laying farms, they're delivered to the farm at about 18 to 22 weeks old. So the birds have already been grown in another house for that period of time and then brought to this other house where there's laying baskets in there, and there's different racks and things that the birds can get up on and to lay their eggs in these little hatches. And so it's they go from one farm operations totally different than going to the breeder farm. So at that age rate, they're there. They produce eggs just for human consumption, or they produce eggs for the integrator to increase their broiler progeny. So rarely any propane or natural gas is used in these houses because the birds are already at that size, making their own body heat and keeps the houses pretty toasty. However, with the lights that are needed and the spectrum needed, it's pretty energy intensive based on the lighting and the fan use. Next slide. So the lighting requirements from broilers are a little bit different. I didn't do one on the breeder because they basically are within maybe a foot candle of each other on needs. But the broiler lights are typically about 1 to 2 foot candles at the bird height for the first week. So when the little bitty baby chicks that come in, they really just need to see where the food and the water is, and for lack of better words, they flock to those areas. And as the birds grow, they then teach themselves where the food and water is, so the lighting is not as direct on them, and so they can reduce that overall foot candle need there to about a half a foot candle, and maybe even less. Some of the newer studies we're looking at is actually even less than that. Like I was saying, the brooding chamber has extra lights down the center. We thought with this program we could go ahead and try different light frequencies and light Kelvin ratings just to see if the birds were going to react to that. The grow out period will last up to 18 days, so they go from 24 hours to light to 18 hours, and some integrators even specify to go to 16 hours. And with the whole house period, that's going to last until the birds are sold, and so they typically will have those lights going on there. So you can imagine that there's a lot of energy used based on a house having 70 plus bulbs in it, running at 18 hours a day, even if they're dimming. Next slide. So the typical lighting used has been just to basically make sure that the birds are getting the feed and water that they need. In days past, the light was usually 100-watt incandescent. So not only were they dealing with high energy consumption rates at that point, but they were dealing with the heat that was produced by these lamps that would cause their fans to run more. So with this new LED technology, there are a whole lot less heat coming off of them. You've got less light lumen output, but we've now understood that the birds are not really needing all that. So in the early 2000s, many growers were learning about compact fluorescent bulbs and cold cathodes cold cathodes to put those in the house to get away from the incandescence. They were finding that there were some issues with the color rendering based on those early bulbs, and also with flickering because they were still trying to dim, and the CFLs they were none available that were actually being able to be dimmed at that time. So the integrators were slow to acknowledge this technology, and they were really worried about bird health and growth. Next slide. So all of a sudden, a big explosion of these bulbs came on the market, and the growers were urged by their integrators, okay, now it's time to replace your incandescents with the CFLs. And they were only telling them to do that as the incandescents failed on them. So they were trying to work them in and say, look, don't go and replace the whole house, but just start replacing bulbs when they go bad with these new compact fluorescents, which the utilities were helping them install those older technology CFLs back then. But the growers were still complaining about the flickering, the short life of the bulbs. They weren't really good on starting in cold weather, but the savings were huge. So they were really on the teeter on, do I make this happen or do I keep going with the incandescents? The integrators still put their thumbs down on them and said, we really would like you to switch over and go with these different bulbs. But a lot of the growers were warming up to that because of the 80% savings, some of them from going to a 100-watt incandescent down to a 23-watt compact fluorescent. So some growers still in our state were still worried about mortality rate because they thought that this new bulb was going to just make their birds die. They weren't going to know what to do in the house. They weren't going to go eat. They weren't going to drink. So they were really worried about the lower feed conversion, which is going to affect them on their contract and what they make per pound or per bird. Next slide. And then along came the LED. The integrators are really struggling with this technology. They had no idea really about it. They have since warmed up to it greatly, but there still was color rendering issues, there were dimming issues, but there were even bigger savings. So they even showed that even with the CFLs, they could still eke by with maybe like a 15-watt or a 12-watt LED. So they were still saving money based on this even newer technology, and some growers were remarking that they were even brighter than the CFLs. Of course, another aspect the CFL had, a downside, was the curlicue aspect of the area and the face of the bulb would tend to have a lot of the poultry litter and dust collect to it, and thereby it would lower the lumen output of the bulb, making the bulbs really dim looking and just not the most pleasant light for not only the growers but the birds too. So, next slide. So again, back to our project. So we've got these farms chosen the 2 broiler farms and the 1 breeder farm. The first broiler farm only had CFLs only. He's had those in there for many years, probably about 5 or 6 years, I guess he'd been growing with these bulbs. The second broiler farm had a mix of incandescent and CFL bulbs, all ranged in different wattages, but for the sake of this presentation, we'll just stick to the bare basics of what those bulbs were. The breeder farm, on the other hand, and this is typical of all breeder farms in Virginia and all throughout the Southeast, is they use 1 row of 150-watt high-pressure sodiums running down the center of the house. Way overlit, in my personal opinion, but I do know that the reason why they use those is not only for the lumen output, but the actual color rendering of that yellow and orange light is good for reproductive growth for the breeder chickens. Next slide, please. So that's what we did. We got data collection equipment. We got the bulbs supplied through us through DMME and through Aaron here at ODEC. A great thing for these growers. They were just tickled to death to have someone come in and bring them something and work with them on this project. They're just out of their minds excited about this. So we looked at the existing bulbs. We counted. We identified it by the Kelvin rating and the wattage. We looked at the intensities with my light meter. We made a lot of different calculations and notes before we even installed the first bulb. We were also looking at the bulb locations. Would they need to run a different circuit to bring the bulbs down further, closer to the litter level? Or were the bulbs that we were replacing going to suffice for our needs? All the 26-watt CFL bulbs were then replaced with 10-watt LED bulbs. The energy monitoring systems were also installed, energy consumption and savings were revealed after several flocks that came and went from the house. Next slide. So here's the real deal on the house number one. So all in all, 65 23 CFLs. We put 65 10-watt LEDs. We got the data from the 2 flocks. So the house that didn't have the bulbs installed in it or had the existing CFLs, it was about 1,193 kilowatt hours per flock. And that's at about, I think he's a 42-day flock. And so $131.23 per flock. So 6 flocks later, he was at $787 for those CFLs at the 23-watt CFL status. When we installed the LEDs, it dramatically dropped to 519 kilowatt hours per flock. And also look at the load difference. So with the CFLs, the 1.5 kW load per house. With the LED replacement bulbs, it dropped dramatically to a 0.6 kW. So basically from 1,500 watts at a given moment to turn all those bulbs on to 600 watts immediate turn on. So that resulted in a $57 per flock, and 6 flocks is $342. So the annual savings per one house, and keep in mind this guy, this particular grower has 7 houses there that could benefit from this technology. But the annual savings was right at $445. So at $15 a bulb, which is typically high amount for an LED bulb, but these bulbs in particular we put in were specifically made for the agriculture industry. Very, very strong bulbs, so they're going to cost more. So with that investment per house, he's looking at a 2.1-year payback, simple payback period. A wonderful thing to do for this grower. Next slide, please. House number 2, same setup basically, but a different ceiling. This grower had a drop ceiling, so the bulbs are closer to the bird level. But he had 55 23-watt CFLs and 22 60-watt incandescent bulbs. And we went in and replaced everything in there with 77 10-watt LEDs. And you can see the same thing, same kW load basically as before. He has a little bit of a different time and run time for his bird flock, for his hours used, for his lighting for his birds, which is kind of common based on integrator and what bird progeny they've got inside the houses. So it resulted in that 6 flock total of $812 versus the 6 flock with the LED, so $344. Okay, and the $8 road drives? Okay, so I was mistaken on the bulb cost. It was $8 for those LEDs. So basically, with that said, I think that payback period would be dropped nearly in half.
Yeah.
So on this particular farm, house number 2, or farm number 2, 77 bulbs at an investment based on changing them out and maybe running a couple different keyless fixtures that were old and raggedy. So about $1,200. And then he's looking at a 2.4-year payback period. So if we were to drop that bulb cost in half, he's looking at basically like a 1.4 or maybe even less payback period depending on the flock timing. Next slide. So the greatest savings we saw was really, kilowatt hour wise and load wise was in the breeder houses. And this is something we're still working on. We're still working with Tyson, the integrator in this particular farm. We're still going back and forth with them if they're even going to allow this newer technology. Now, I will say that these LEDs that we replaced, the 150-watt high-pressure sodiums, is less foot candles, but only by about 2 to 3 foot candle difference. And these birds have not reacted anywhere different to this difference in bulbs at all. The Kelvin rating, it's not quite as yellow, but it's still yellow enough to where the birds were still having their reproductive rates. Nothing was any different. The rate of bird mortality didn't increase or decrease. The productivity of the birds stayed about the same. Now, given this house with these birds, we're in the middle of the flock. So typically when the birds are newer and younger, it takes them a week or 2 to get used to things. So that's really where the rubber will meet the road on this technology, if it's going to work or not. But the proof's in the pudding on that. 5.6 kW load per house dropped all the way down to 1.05 kW based on that bulb switch. So you can see the annual savings per house at about $656. And now these bulbs are more expensive because of the lumen output and the size of them and just overall build quality. But he's still looking at a 2.7-year payback period. That's perfectly within the lines of something that they would be willing to replace based on an under 3-year payback period. Next slide. So again, no difference really in the production increase or decreases from the broiler farm to the breeder farm. It was just really a great thing to understand that and know that that's really what's going on. We all have fears on newer technologies. We don't really want any grower to lose their contract over putting some crazy bulbs in that we think are going to save energy. So we had to watch ourselves on it, but we're really, really excited that there's been no differences. And again, the growers have been overly pleased with not only with the study to see where the energy is going and how we're conducting all this, but the equipment installed, they're just really tickled with it. Next slide. So advancements needed. We are finding some things that we could let the bulb manufacturers know for agriculture that would be more specific to their needs based on build quality and rendering and overall output and possibly even the spread of the bulb as far as how the light is spread when it leaves the bulb surface. We are excited that the prices are coming down monthly, it seems like, for these bulbs. And they need to be made for that corrosive environment. A lot of times these growers put in just bulbs they found in Lowe's or Home Depot or a big box store, and they were sad to learn that they only lasted for a few months because it's very corrosive in there. And I would like to see in the long haul that we could start putting in solar tubes or something like that to gain a lot of the sunlight that's hitting the roofs of the houses and has never made its way into the houses because a lot of these houses are solid sidewalls now, so they're not getting any natural light. We'd like to see that mingled with some of the artificial lighting and being able to dim them as the sun comes up and then bring them back full on when the sun goes down. And then also just more robust data collection because there's a lot of different requirements from each integrator on what they're allowing and what they're not allowing. Next slide. So anyway, the bottom line and how impactful this study is that Virginia's got about 6,000 poultry farms. North Carolina probably has 18 to 20,000. Within those farms, there might be only one house, there might be this or that or the other. But in Virginia, we know just in this segment of farms that we kept this within the geographic location of like Southside Electric Co-op that's part of ODEC. And within that area, there's 70 breeder houses alone. So if you look at all the counties that have commercial poultry in them, and just in Virginia, we're looking at tons and tons of farms that could be make these recommendations a real priority and make them happen, as long as we get the okay from the integrators to let these things happen. So if you think about that, with 1,200 farms that we've been around here in Virginia that probably haven't made the change yet, we're looking at probably close to 15 megawatt hours saved that could be there potentially if these growers made the change. And the bottom line we're looking at is the breeder and layer houses. We really want to make a push to try to get them on board with this idea and this technology to help them save. And then the next thing we're going to look at, I think, down the road with dairies and with even with poultry is just the fans and pump motors. We see a lot of inefficiencies there. We'd like to see a lot more variable frequency drives within these farms and so on and so forth. So, as it says, to be continued. Next slide, please. Thank you all very much.
Great. Thank you, Aaron and Josh, for your informative presentation. I know for us here at BAAC, this is one topic that we're not familiar with, which is why we're really excited to have this webinar. Just as a quick reminder, if you do have any questions for our presenters, please type them into the chat box and we will ask them on your behalf. And we do actually have one question already. This comes from Jill Ferguson. Question from ACEEE. I'm an energy researcher at ACEEE doing a framing piece on using energy efficiency policy as a tool for economic growth in rural agricultural industry and rural households. I'm in the step 1 energy analysis phase, as you described, trying to mine rural energy use data and energy burden information. So she has a couple questions. One, where do you get data on energy electricity use in rural communities beyond the EIA RECS survey? And 2, how do you define farm and rural? There are multiple USDA continuum codes and census definitions. And 3, what do you see as the energy efficiency program opportunities?
So one, the question was about where do we get the data on energy consumption? Did I understand that correctly?
It says, where do you get data on energy electricity use in rural communities beyond EIA?
So for the electric cooperatives in Virginia mainland, I think it's safe to say now that all of them have AMI systems in place, and we can get even down to hourly interval data for the majority of the member consumers out there. Now, when you're looking at a specific house, if the metering is on an entire farm and not the specific house, it gets a little bit more challenging, but that's where we have invested in this monitoring equipment called the Energy Detective that Josh can speak more to how it actually is wired and works, but it gets the consumption data directly off that circuit. So that answers the question about consumption, I think. The second question was, remind me again.
How do you define farm and rural? There are multiple USDA continuum codes and census definitions.
So, how do you define farm versus rural? Well, rural is more like a geographic. It's the rural versus urban versus suburban. A farm is defined, and I'm not sure if it's a tax definition as far as how a farm is defined. So when it comes to funding opportunities through USDA, RD, or NRCS, we rely on their definition.
Real quick, their definition of rural is 50,000 or less in a given area. And that's through rural development. When someone is submitting an application for the REAP grant, they have to be in a rural area, which typically would mean that there has to be less than 50,000 population in that given area.
Is it the main?
Right.
Yeah.
And as far as the classification on farm, I do think that typically it falls under their classification of what their taxes say. So if they file a Schedule F, I do believe that would mean that they are a farm. I don't know if that answers the question, but.
Great. And the last piece of her question is, what do you see as the energy efficiency program opportunities?
Well, right now, Virginia, I think the only thing going right now for farms in Virginia is for REAP. They accept applications throughout the year. I think that probably is another segment we could get into REAP about the do's and don'ts and the ifs and whatnot with that program. But NRCS did have funds in previous years for implementation of the recommendations found in the audit. However, this year, and I think most of last year, they have extinguished those funds, and they do have things in place for growers to have an audit written for them or conducted for them. But as far as the implementation, there's no funding right now for that through them.
Great, thank you. Are there any other questions that anyone wants to type into the chat box? That was the only one that we had received so far. We'll give some folks a chance to finish typing if you are typing. All right, well, we don't have any other questions coming in, but if you do have any, we will be sending out an email with Josh and Aaron's contact information, along with an audio recording of this in case there were any issues or if you would like to refer back to it. I know all of you already have the presentation in hand that was sent to you earlier today. So we thank you so much for your time. I think our next scheduled webinar is in September, so this is our last one for the summer. But thank you for joining us today, and we appreciate you spending your lunch hour with us. Take care.
Thank you all. Bye.